Great to have you on this week's Pascal's China Lens. We're going to talk about the smallest thing on this planet almost, semiconductors. And very often when I talk about China will lead the world in global innovation by 2030, I always get people challenging me saying, yeah, but look at semiconductors. They're in 28 nanometers range, they're at 40 nanometers, we're already at 5 or 3 nanometers. When the world becomes really complicated and you need to get the geniuses out of this world, China just can't catch up. Is that true? I'm going to give you a little bit of different insight. Don't forget to hit the subscribe button so you can follow all my videos in the coming weeks, because there's a lot more happening in land of China and innovation. We're going to talk about something quite cool. Microelectronics, chips. This is something the most advanced in the world to develop. And what is China doing today? Because in the media you hear a lot of stories that China is trying to catch up with the West, specifically the US, which is leading all semiconductor industries. And so how is China ever going to catch up? Some people say it's going to take a decade, 2 decades at least, before we can talk about it. Is this true, or is this maybe more a story like the high-speed trains, where suddenly, out of nowhere, they become the market leader? Or maybe solar panels, or maybe it's something like drones. Is this the same? Well, it's a little bit more complicated, because building a chip is very, very complex. And if you look at the last years, that's where they went from 40 nanometers to 7 to 5, now to 3, maybe 2 nanometers. I mean, we're getting on the edge of what is physical possible. I mean, we're getting at atom level. And that means that at one point you just can't go any further. And so can China keep up is maybe more the story than can they catch up. Because these are the last miles that China needs to do. Now, just 3 months ago, the Huawei announced that they will have this new chip available, which has been tested and proven and works, which is the Kirin 9000 in their Mate 40 series, which has 15.3 billion transistors on this little chip. I mean, that's twice as many transistors as there's people on the planet. This is mind-boggling. And they designed this. So saying that China is behind is kind of like weird. But reality is they didn't manufacture it. It's the foundry in Taiwan called TSMC, the biggest foundry in the world, that manufactured this chip. 5 nanometers. Really great technology, better than Apple at this stage for their iPhone 12. But anything you read in the media these days, it's all about China has not succeeded in chip manufacturing. I mean, the memory chip project went bust. If you look at what happened in Wuhan with TSMC, I mean, they could not reach the 7 nanometers that they predicted they were going to reach. Tsinghua University, or Uni Group, has real financial troubles. And ultimately, only 6% of all the chips that China produces is actually being used for China, which means they're still importing $350 billion worth of chips every single year, 96% of all the chips. So they're not doing that well, if you look at it that way. Now, the issue is that it's a lot more complicated than before. And what it means is that there's so many components that you need to be an expert in that it's very hard to invest in every area and be the expert at the same time in every area. And nobody in the world wanted to continue doing that. If you look at Boston Consulting Group, their report, it looks like America is leading on every front. And I would agree, on many places, when we look at software tools or core IP, then America is doing really well. And ARM, which is a core IP from the UK that's now part of Japanese technology, they're actually leading this pack. But on every other aspect, I think it's a lot more complicated. And we need to look at this in a little bit more detail. The issue is that back in the 70s, everything was integrated device manufacturing, or IDM. It means everything on that long list is what one company did. Think about Intel. And later it's Samsung. But those two are kind of like the only 2 big ones remaining. Everybody else has kind of decided we're either going to be a foundry, or we're going to be an equipment manufacturer, or we're going to be a designer, or do some research, or build some EDA tools. Or everybody's making their own decisions where their expertise lies. And with globalization, that was not a problem. And so we have to look at all these different parts, because now with the trade war and with the blocking of China of getting US technologies, the problem is China's forced to go in every area, not just one or two areas. Before they didn't do it. Why didn't they do it? It was too easy. They could just buy the chips or buy the tools or buy anything they wanted. Why did they have to build it themselves? US thought the same way a long time ago. That's why they don't have a lot of foundries in the US anymore. But if we look into more detail, resources or raw material is quite important. And silicon, as well as gallium, is where China's really leading. So they could make it also more difficult for the rest of the world in some instances. Now, R&D is where it all happens. There's research, there's tools, there's development, there's design, there's a lot of things that happen before it goes to manufacturing. And research like IMEC in Belgium is really top-notch in the world. Now, China does have research institutes, but they haven't been investing enough into it. That should change in the next 5 years with the 14th five-year plan that they're now implementing, but it's going to take some time. But reality is China is investing as much in R&D as the US these days. The only difference is that the R part, the research part, US is still developing or investing twice as much as China. It's like 18% of R&D, while China is about 8% of R&D. And that is now about to change. And that will take probably 5 years before China really gets at the same level as the US in terms of pure basic research like IMEC is doing. But there's no lack of capital, and talent always flows to where there's capital. Where you want it or not, that's how US got so many experts in silicon design and silicon manufacturing coming from everywhere in the world. And China's now doing the same. The key story here is manufacturing and the foundries, because that is where it's really, really hard these days. And if you look at the market share in revenue, then you see that TSMC, the Taiwanese company, as well as Samsung, together is 75% of the market. They're kind of a duopoly in the market. So they're generating more revenue than anybody else. And that has to do a lot with the fact that they have focused on these high-level chips, 5 nanometers, 3 nanometers, while the others are still using less difficult to develop chips, which means they're making less money. Now, if you look at fabrication capacity, there it's a little bit different story. China's not doing that bad. But what I think is interesting, regardless of how you look at it, is that foundry-wise, 80% to 90%, whether it's revenue or fabrication capacity, is actually coming from Asia. So saying that China or anybody in Asia would be behind the US is completely false. China's not behind the US. They're behind Taiwan and behind Korea, yes. And why are they behind? Because of the machinery that is needed to build these high-level chips, these nanometer chips, 3 nanometer, 5 nanometer. And you see that companies like TSMC and Samsung were already there in 2019 to build 7 nanometer. China and Intel only started in 2021 to do this, and it's going to be 22, 23 before other companies chip in China. So they're like 4 years behind Taiwan and Korea. When you look at the 5 nanometers or 3 nanometers, it could take another 5 years to 10 years maybe before they catch up with Taiwan and with South Korea. But it's all to do with the machinery, because you need this light lithographic machinery from ASML, a Dutch company, which actually gives you the possibilities to develop these chips. And this is the only company in the world that can do it. So this is not a US company. So what's really happening is that China is getting blocked to develop because they can't get access to a Dutch equipment manufacturer, ASML, while everybody else in the world can get it. And so TSMC can get it, Samsung can get it, and if they wouldn't be able to get these machines, they wouldn't be able to develop these chips. And so there is something strange happening because America is blocking Netherlands to export these products to China. So it's becoming a very geopolitical thing. Now, when you look at OSAT, or the outsourced semiconductor assembly and testing equipment and production, then it's really clear that everybody can do it. It's not that difficult anymore, and China's doing quite well. Everybody else is like Taiwan, it's like Korea, it's America. I mean, everybody has like their experts. On the distribution level, and I mean the supply chain, those who package these chips together with a cell phone, for example, their Foxconn is the leader in the world. That's what Apple's using. But most others are in Asia. They're in China or Taiwan. And so it's very clear that this is not the bottleneck. The real bottleneck is actually the EDA tools, the software tools to design the chips. It's some of the IP. It's actually some of the equipment, like from ASML, and the capacity of the foundries in some fashion, but I don't think that's going to be the main issue. Now, what's happening today is quite interesting, because recently you hear a lot more reports that the whole industry, specifically the automotive industry, has a lack of chips, computer chips or semiconductors, whatever you call it. They can't get them. There's not enough supply into a world that now has become completely digital and everybody wants these chips. And what's interesting now is because TSMC and Samsung have actually focused on these very high level chips, 5 nanometer, 3 nanometer, to make more money and to develop those more complex things that nobody else can. Because of that, they haven't built out enough capacity for the other chips, which is maybe 95% of the rest of the market in terms of number of chips. And this is an opportunity for SMIC. SMIC is the biggest foundry in China. They're being blocked by the US now to get lots of materials, to get the ASML equipment, although ASML is giving them another year of equipment, so they can probably get to 7 nanometers, but beyond will be really hard. But somehow SMIC now has an opportunity to make lots of money because the rest of the world simply can't build the capacity anymore. And so China's building up money. And that's interesting because this came at the same moment as just 2 weeks ago at the 14th 14th five-year plan of China that was announced that they're going to invest massively into this new chip industry. And the last 5 years, it was really like, yeah, we need to become stronger. But now it's very clear that the politicians have said, we're done playing. Right now, it's getting very, very serious, because unless we're going to focus on basic research and become the best in the world to develop these chips, we're always going to be dependent on the rest of the world. And they're pouring in billions and billions of dollars in order to make it happen. And I believe that this will create a new market. But it would be wrong to think that because the government is giving money, that this will actually create the difference into competing with the US, competing with the rest of the world. The real reason why I believe that now today China has a real chance in the next 5 years to catch up with the US and with Europe and with even Taiwan on foundries is simply because it's now market-driven. And if you've looked at all the big tech giants, whether it's Baidu or Tencent or ByteDance, or Xiaomi, Oppo, all of them are now investing in building their own chips. Together with partners, they won't have their own foundries very often, but they're investing in these foundries, they're investing in these designs, in these tools, and they have the market to sell it to. And so this becomes now an industry market-driven demand, which is very different from before, where they could just buy the chips and didn't have the need to develop it themselves. And that's why I believe that China today in the semiconductor manufacturing is at the base camp at 6,800 meters high at the Everest and still needs a really tough time to get to the mountain top. But that part is maybe the most dangerous, and a lot of companies will die in the process. But they will get there simply because the consumer in China will want them to get there. So what do you think? Do you think China will really catch up in the next 5 years like they want and I predict? Or do you think there's going to be the rest of the world blocking them and they're going to be delayed maybe with 5 or 10 years? Or do you think maybe there's going to be a war in Taiwan because of it? Because the geopolitical tensions are going crazy? Or maybe China is going to start blocking us to get certain components? What is happening? So all these possibilities, the only way to know it is to keep watching what's happening in China. So do keep watching my videos. That's what I would suggest.